All right, so this is a general rundown of what we're going to be doing in Chapter 8. So Chapter 8, what we're going to be doing is we're going to be testing claims, and we're going to do this through a very specific process that I'll show you in the book. So this process is going to look at we're going to start with a claim. We're going to start with the claim, and then we're going to find some. We're going to have some kind of significance level as opposed to a confidence level, and so we're going to look at the tail as opposed to the area in the middle. So it's very, very similar. And then we're going to find our critical values, which is kind of what we've already done before. So for proportion, we're going to find z alpha over 2. For means, we're going to use t alpha over 2. Assuming that we don't know sigma, and then for the for doing the variance or even the standard deviation for either one, because they have the exact same critical value, we're going to use either your chi-squared left or your chi-squared right. So this is the gist of it. Is your critical values again. So 8.1, our critical values are for proportion are going to be your z alpha over 2. For your mean is going to be t alpha over 2 mostly, but sometimes it'll be z alpha over 2, and this is only if sigma is known. But more often than not, we're using this one. And then for your standard deviation or your variance, we use a chi-squared left and a chi-squared right. So now from these particular things too, you're going to have to be able to find our test statistics. So our test statistics are calculated by, for proportion, let me make sure I want to put these equations in here. I got to memorize, but I want to get them down. So our test statistics for proportion, test statistics. So for proportion, our test statistic is going to be a z-score because this is our critical value. So what I'm going to be doing is I'm going to be looking at these two particular numbers. I'm going to look at a test statistic that comes from our sample, and then this is going to come from our confidence level or our significance level, and I'm going to compare these two z-scores. So this z-score is going to be calculated by p hat minus p all over the square root of p hat times q hat all over n. So really, this is just a z-score that's actually calculated from your normal z-score. So I don't really want to prove it to you because time is of the essence. But how it's done, and you can kind of do it yourself, is that you know that z is equal to x minus mu all over sigma times the square root of n. So that's how your z-score is. Now what you know is that that mu is equal to n times p, and x bar is equal to, n times p is actually n times p hat. And then you know sigma is equal to the square root of n times p times q. If you plug all those things into that formula, it simplifies to this thing. So really this is just kind of from the binomial. So none of this is needed. This is what we're looking at, okay? But that's how you get here. So this really is just a z-score. Now for a mean, more often than not, we use a t distribution. So your t is going to look, honestly, it's very similar to this thing right here. It's going to be x bar minus mu all over s divided by the square root of n. Now this is if sigma is not known. And then if sigma is known, we'll use a z-score. So this is going to be x minus mu all over sigma divided by the square root of n. So this is if sigma is known. So we usually, it tends to be this over this more often than not, because it's kind of rare that we know sigma. It's kind of rare that we know the mean and not know sigma, because they're related to it. Or knows, yeah. Okay, and then for the standard deviation or the variance, so standard deviation or variance, our our critical value is going to be equal to, our critical value is going to be our chi squared. And what this is basically that formula that we had before, just solve for chi squared as opposed to solve for sigma. So really this is the same formula we did in the previous section. It's just, if you switch these around, you can see that that's where the confidence interval comes from. So we're going to look at, we're going to test these versus each other and see where we live. All right, so what we're going to be given is we're going to be given a significance level. Significance level and a confidence level is very similar. Essentially, this gives us the area in the tail. A tail or an area in two tails. Now, I'll have to talk about the tails now because sometimes it really depends on what we're testing for. Are we testing for less? Are we testing for equal? Are we testing for greater than? So what we have to do is we have what's called the null hypothesis. So we'll have to get back to this. So our null hypothesis is it's denoted by, so what we do is we say this is H naught. A null hypothesis is a statement that the value of the population parameter is equal to some claimed value. So this is that the value of the parameter is equal to the claim. Now the alternative hypothesis, this is denoted by H1 or HA. So this is denoted by I'm going to say H1, but you can use H1 or HA or H capital A. And this is that I should do this in colons. So this is that the statement of the population parameter has a value that it somehow differs from the null hypothesis. So differ means it could be below, above, or not equal. So that the value of the parameter is different than the claim. So different could be, it could be less than, it could be greater than, or it could just be not equal. It could be on both sides of it. So it could be both, either less than or equal. So it kind of depends on what they're saying. So one-tailed versus two-tailed. So what we have is we have a left-tailed, we have a right-tailed, we have a two-tailed. So if the claim is about less than, if the claim is our parameter is less than some value, what we have is we have this value right here, which is going to be is going to be the claim. So this is going to be our claim. And what I want to know is I want to know if the value is less than the claim. Now, to just be barely less than the claim is not good enough. Remember that as we repeat things, there's always fluctuation in here. So the question is, it's got to be less, but it's got to be far enough that it's not statistically equal. So somewhere out over here is going to be what I consider significantly low, right? You guys are used to significantly low and significantly high. But if I'm only checking less, the only thing I care about is your significantly low, the one that's below. So what I need to do is I need that this value right here to actually be inside the tail for this to be true. So if I say, hey, this value is less than the claim, then it's got to live inside here. Because if it lives in here, then it's not. So what we'd say is this area right here we'd call the null hypothesis because this is what we consider equal to the claim. And this area right here is going to be our alternative hypothesis, which we say this is the area that it's less than the claim. Now what's going to go over here, this spot right here, is going to be our this is going to be our critical value. So this is going to be our critical value. So it could be a z-score, it could be a t-score, it could be a chi-squared. In this case, it would be a chi-squared left because chi-squared lefts are over here, chi-squared rights are over here. So what we're going to do is, once I know the claim, because it's going to be given, and the critical value is actually going to come from the significance level because the significance level is very similar to a confidence level. So, these things are going to be tied together. So I'm going to know these things right from the sentence. So the calculation is going to be the calculation in our test statistics. So let it be this, this, or this, depending on what I'm testing. So if I'm testing proportion, I'm going to plug in, your sample, the claim, and then all of this stuff. I think I got that wrong. These are not hats. This is P and this is Q. Those are not hats. So then I'm going to plug those things in. So that value is either going to live here or that value is going to live here. It's either going to live below that critical value or above the critical value. If it lives it below, it's in the alternative. It means it actually is less. If it lives here, here, anywhere in here, then it's not less. It's what we consider statistically equal. It's in that area of fluctuation. So that's kind of the goal here. So this is what we call a left-tailed situation. So this is left tail. If it's left-tailed, this area right here is actually equal to alpha. So the area is equal to alpha, where this spot right here is going to be your null hypothesis. So the area has to do with what we consider less. So if I say it's a 95% confidence level, this is going to be 95%, and this is going to be 5%. So we're used to having two-tailed things because we've always had two sides. Well, this is going to be a one-tailed thing because we have one side. So your less than and your greater than are going to be one-tailed situations, and then we'll get to a two-tailed in a second. So in this case, this is situation 1, this will be situation 2. So what if the claim is the parameter is greater than some value? So what we have is, your claim is going to be the center spot. So this is going to be your claim value, whatever that might be. And now what we're doing is we're determining if it's going to be greater. So what they're saying is they're going to be greater. So this is going to be H naught. This is going this area here essentially is your null, which basically represents equality, and this represents greater than. So remember, I don't really care about the size. The size is dependent on what you want your significance level to be. So if it lives in here, it's equal. If it lives in here, it's greater than. So this is the greater than area. This is the equal area. Again, you're going to have, this is going to be your critical value. It might be, it might be Z alpha over 2. Sorry, it might be, if it's only one-tailed, this is going to be this will be negative Z alpha or negative T alpha or chi-squared left. Since it's over here, this is positive value. So this is going to be positive Z alpha, positive T alpha, positive, chi-squared right, because it's on the right-hand side. And the reason why I'm only using alpha as opposed to alpha over 2 is because I only have one tail that I'm concerned with. So, this might be a Z alpha or a T alpha or a chi-squared right. This might be a negative Z alpha, negative T alpha, or it's going to be a chi-squared left. So those are the type of critical values depending if I'm doing proportion, mean, or standard deviation. Proportion, mean, standard deviation. Now your third situation is going to be, your claim is going to be about equality. What if the parameter is equal to some value? Well, if it's equal to some value, what I mean by that is, what I mean by equal is if this is my claim, I need to be close to this, but close enough that it's not considered too small or too large. So in this case, you're going to have two particular tails. This would be not equal because it's too small, and this would be not equal because it's too large. So, together these are the alternatives. Your null hypothesis is always the area of equality. So this is the area of equality, and this is the area of not equality. So, this would be considered less than, this would be considered greater than, and these things would be considered not equal. So this is, this is what H naught represents, okay? So this is H naught less than the claim. This would be H naught greater than the claim. This would be, H1, because this is equality and this is outside equality. So H1, not equal to the claim. So when we set these things up, again, this is going to be, let's just say we're doing z-scores here. So this would be negative Z alpha over 2 because there's two tails, and this would be positive Z alpha over 2. So then what we do is we'd still have a test statistic, and that test statistic would be right here. So if I'm doing the z-score, I'm plugging this number in, and I'd find this value, and I want to know where this value is going to live. Is it going to live somewhere in here? Is it going to live somewhere in here, or somewhere in here? If it lives in here, then it's equal. Then it's equal to the claim. If it lives in here, then it's not equal to claim. It's too big. So the way we set up our claims is I kind of set this up already. The very first thing is we say that H naught is always going to be considered equal to the claim. H naught is equal to the claim. So I didn't write, there should be some little space here because I don't have a particular value because I'm either testing like it's either going to be the proportion. So if we're talking about proportion is equal to the claim, proportion is greater than the claim, H naught. Proportion is equal to the claim, proportion is not equal to the claim. So we're going to have our hypothesis, and we'll do this a little bit better later, but I'm trying to discuss where this comes from, and it's complicated, to be honest. But we'll get very, very good at this, okay? What's kind of nice about 8.2, 8.3, and 8.4 is they're all done exactly the same way. All your steps are identical, except the fact that you use a different critical value in a different equation. So, but the steps are identical. You just, these things are all calculated on your calculator. You just have to find the values and plug them in. So it's really, this is kind of a nice section once you get used to it. Okay. Okay, back to this. So let me talk about this, the way that we do this. Rather project it as opposed to write it. So what we have here is we have a procedure that we go through to be able to find these things. So number one is identify the claim. So identify the claim to be tested and express it in symbolic form. So if they say the proportion is equal to 50%, what you'd say is P is equal to 0.5. So that's you represented that in form. Given the symbolic form, that must be true when the original is false. So if I say P is equal to 50%, then I would say that P is not equal to 50%. So this is one side of the coin, this has to be the other side of the coin. Because you're either equal or you're not equal to. So the idea is you want to find both pieces. What they're trying to do is these two symbolic representations are actually written as your null and your alternative. So your null is always going to be the equality part. So in this case, since I claimed equality, this is going to be your null. So P will be equal to that 50%. And then your alternative will be P is not equal to 50%. So this one's always the equality. This one's always the one that doesn't have the equals. Significance level. So significance levels tend to be given to you. Most of the time we use 0.05, but sometimes they're special. Maybe they might say 0.01. This kind of corresponds to like a 95% confidence level in a way. After that, we're going to identify the test statistics. So we're going to calculate that formula, and then we're going to figure it out. So the p-value method and the critical value method are basically two ways to do this, and I'll kind of show you with a little bit of graphics what they mean. So what I'm going to do is I'm going to kind of set up a quick situation with just general numbers and explain what happens here. So let's say our example here is the claim is that the proportion is less than 25%. And I'm going to use a 0.05 significance level. So what I do in step one is a symbolic representation for the claim. Well, the claim is that the proportion is less than 25%. Number two, really the opposite of that claim, is that if your is that P is going to be either greater than or equal to that 0.25. So step three says what I have to do is I have to determine what one's the null and what one's the alternative. Well, the null hypothesis is always the one that includes the equality. So this is the null hypothesis. Now some books use P is greater than or equal to 0.25. And some use just P is equal to 0.25. They don't really worry about the greater than. So they tend to do it in this particular book. They just drop the greater than or equal. So if it has the equal, just going to consider it equal. Now the alternative hypothesis is going to be the other one. So this was the null because it has the equal sign. And this is going to be the alternative. So P is less than 0.25. Step four, they say determine the significance level. So alpha is equal to 0.05. So, in number 5, we're going to do a test statistic. Well, since I'm testing proportion, that means z is going to be equal to p minus, should be p hat minus p. Mix this up. So z is equal to p hat minus p all over the square root of pq all divided by n. Notice how this doesn't have the hats on it. So in this situation, this doesn't have the hats because we're actually we're investigating the claim as opposed to the sample, okay? So we're centered around the claim as opposed to being centered around the sample in the previous section. So that's why these have no hats on them. So this is going to be equal to some number, and we'll kind of determine what happens here. So number 6 says, well, we're either going to use a critical value method or a p-value method. So what we have here for number 6 is, in this particular picture, what I know is that our alpha is equal to 0.05, and since we're less, we're actually talking about a left tail situation because we're talking about less. In the area in that tail, alpha is equal to 0.05. So what this 0.05 is going to give me a critical value, which is a T alpha, which is tied to that particular level. Now, n is going to be given because remember that we've calculated this, so we're going to know n. So let's say over here n is equal to, it doesn't matter. We'll get there. So T alpha, you're going to be able to find that. You already know how to find T alpha over 2. So T alpha is not found any different way. What you need to do is you need to know n, and you need to know that area in that tail, and you just map the degree of freedom to the area of the tail, just like we did with the t-score table, okay? So the two methods are we can find your critical value and then look at these two numbers, or you can find the area of that particular number and then investigate the areas. So you can either investigate the areas, which is your p-value method, or you can estimate your critical value. So say I have this. Say what I get here is, so this is the setup. So what we know is this is going to be 0.05. And let me get it right. So let's say this is that 0.05, and this is going to be our T alpha over 2. Remember, this is our claim. This is our claim, which is P. This is our claim, which is P in this particular situation. So this right here is going to be your T alpha. Sorry, your Z alpha, because we're doing P. My bad, Z alpha. Z alpha. So let's say that our test statistic lies right here. Say if our test statistics lies right there. So this is Z alpha, which is a Z score, and right here is going to be your Z, which is calculated by this formula, okay? So that right there is your Z. So let's say that this calculates a number less than this thing. So let's say this is equal to negative 1.96. Let's say this Z-score was equal to negative 2.31. Notice that the Z-score is going to be less than that. So that means that this Z-score is less. So that means that means this thing lives in the less than parts. The less than parts, which basically is the null. So this is therefore this is not the null, but the alternative. This is the alternative part. So the quick question is, would we consider this equal? Would we consider it here? Is it equal or is it less? Well, since it lives in the less than part, then it's going to be the less than part. So what we'd say here is we would reject that null. Oh, I forgot to talk about the areas. So the critical value method says we look at these two numbers and determine where it lives, left or right of that particular line right here, right? Or we can use the areas. Now, if you have a Z-score, you can map this 2.31 back down to an area. You know that this is equal to 0.05, and if I go to a Z-score table and I look at negative 2.1, so negative 2.1, I get 1.797, I get this number, so I can tell that this area is less than 5%. So this area is, 0.0179, I think. So I'm running out of time, I'm going to be somewhere in a minute. So you can either look at the areas. So this is the let's say area. So you can look at the areas. So if this area is less than this area, it lives in the value, or if this value is less than this value, then it lives in that. So you can either look at the areas, which is this is called the p-value method, and this is called the critical value method. In both cases, you get the exact same thing, that this lives in the alternative part. So we have some wording. So these are our situations. So wording for final conclusion. So if the original claim does not include the equality, kind of what we have now, it did not include the equality. The claim. What's the claim? Yeah, the original claim did not include the inequality. So we're either here or here. So, but we rejected H naught. So in this case, what we're going to say is we're going to reject H naught because remember this is H naught and it's not in there. So since it's not in H naught, we reject this. That means the alternative must be true is what we say, but we don't ever say this is true or this is true. We either accept the null or we reject the null, okay? So in this case, so we're going to reject H naught. So these are our wordings. So the original claim does not include the equality and you reject H naught. So this is what we actually say for the last statement. Now, if it did live in the null as opposed to the tail, then this is the statement we do. Now, if the claim was about H1, then the wording would be different. Okay, so you can kind of read through the book and show the other examples, but this is really basically the best breakdown I can do of it. If this is kind of confusing, when I go through 8.2. This will become a lot clearer because right now I'm not using any real numbers, so it's kind of hard to see. So in the next 8.2, 8.3, and 8.4, watch the videos and this method will become a lot clearer, I promise.